Thank you all for bearing with me again as I talk about some energy stuff. Again, I teach a renewable energy course here at the University of Minnesota. I'm trying to compact what we do in 14 weeks down to just a few lessons for you. So I move fairly quickly, so I'm happy to answer questions either now or after class. If you guys want to work through whoever your instructors are to send me more questions, I'm happy about that. So last time we got cut a little short because I was confused about the time and my technology didn't work. So I'm just going to recap a little bit about what I thought was important. I'm going to try and talk slower than I want to, because I want to talk really fast because I have so many things to cover. But we're going to do just a quick review, and then we're going to get into some of the transitioning, how we're transitioning our energy system into something a little bit more maybe sustainable, and how we're going to do that. So quick review, that we are continuing to grow our energy consumption. That not only is it because of the population rising on the planet, but we also have a gap here that is rising faster because people are making more money and they're choosing to buy washing machines and gain electricity. We think that's a good thing. The challenge is, how do we keep up producing more and more energy and make it greener at the same time? Cleaner, cheaper, greener. If I look at when I was born, about 1960, we can see that almost 100% of our energy supply, the green, the gray, and the red, are fossil fuels. Almost 100%. There was a little bit of blue. This blue is hydro. Globally, it was about 95 or 97% of our energy was fossil fuels. We're actually doing better now. Right now, it's 85% is fossil fuels. The rest is this clean energy up here, which is nuclear, hydro, wind, solar. So we're doing the best we can transitioning, but it's been 60 years and we still have a long ways to go with that. That was a global picture. We know that locally, country by country, those numbers change because of what is locally supplied. So South Africa has a lot of coal and they use a lot of electricity. They maybe don't use as much petroleum for transportation, and they have very little natural gas, but they are up at about 97% of their energy in their country is supplied by fossil fuels, where you come down here to Sweden and only about 27 or 28% is supplied by fossil fuels. So there's a big diversity, and it has nothing to do with politics, nothing to do with saving the world. These are energy sources that they have in their country that tend to be cheaper, and allows them to use those different energy sources. Colombia and the US are very similar. We have about 85% of our fossil fuels are from or our energy sources from fossil fuels, and you are at about 80% from fossil fuels. You can look at your hydro, though. 23% of all your energy sources from hydro, which is really good. You have way more supply of rivers and streams that can be used for hydro than we do in the United States. And the other piece that we talked about was that every energy source, so if we look at petroleum or natural gas or coal, they need to be replaced by a fuel that does the same work. So when we think about petroleum, 68% of our petroleum supply, so this is this line here, this is our sources. So petroleum, natural gas, renewable energy, coal, and nuclear. If we just break out the petroleum and we say 68% of our petroleum goes towards transportation, and we can follow this line to here, and it says 90% of all our transportation here in the United States is from petroleum. So we're going to talk about that in a little bit, but just remember that each energy source has a specific use based on the cost, based on its liquid fuel versus solid fuel. Natural gas, we use about 33% for heating, 33% for electricity production, 33% for industrial products. So both these products, we use petroleum for plastic. We use a lot of plastic. The planet uses a lot of plastic, unfortunately, but we can use also things like fertilizer is based on natural gas. So we can use natural gas both for the heat in industry and also for making those products. Coal, about 90% of our coal goes to electricity. So the important piece is that we have specific uses for each type of fossil fuel. So moving forward, that should have been what we learned last time. Maybe we learned a little bit about how I can save energy, or my energy use is both direct energy use when I buy gasoline to fuel my vehicle, or when I pay for my utilities to turn on my electricity to power my computer. Those are direct energy forms. Indirect energy forms are things like the hospital, energy used to build the hospital, energy that's used to maintain the hospitals, the roads, the bridges, all that stuff is indirect energy that I have less control over. Those are the things we talked about last time. So transforming our energy system, we want to think about, and we kind of ended with it, and I'm going to this is my key here to remind me, when I have something in blue, I would love to have some input from the class and just see if this works. What is it that makes a good energy source? So I'm going to think about it in three things, and I think you mentioned two of them, but I think there's one that is not as, that is very important. And I'm going to say one is cheap. Our system of energy has allowed us, our use of fossil fuels, because they are cheap, has allowed us to build economies. If we were still working with horses or human power to build pyramids or to build our infrastructure, we would not be where we are today. So we needed cheap energy. So that's, I think, is number one, that we like cheap energy. And that is one of the problems we have now, is we have gotten really used to cheap energy. And we'll talk about that a little bit. Reliable was that, is it abundant? Do we have a supply, adequate supply? So can we get it, and can we get it anywhere we want? When we walk to our light switch, can we turn it on and expect that the light will come on because our electricity is being generated and brought to our house by our utility company? So we have that. The reliability. So is it, and we're going to talk a little bit about energy security in a second, but reliable means that we can use it anytime we want. This is super important as companies also. A manufacturer of clothing or of cars needs a cheap energy source, and they need it to be reliable, so they aren't having to shut down their plant, their factory, because they don't have energy there. All right, and the other piece that's pretty common is that it has to be clean, and we've ignored that in the past because we didn't think about fossil fuels. Fossil fuels up until a few years ago were perfectly fine because we didn't understand that there is an issue with greenhouse gas emissions and with other human health environmental impacts. We can also see that these are tied together. So if we say we want cheap, and that costs money, possibly, if we want it more reliable, or if we want fossil fuels to be cleaner, it's going to cost us more money. So these three pieces are really tied together when we think about our energy system. We can right now, we can put filters on coal plants so they can emit very little carbon dioxide, very little greenhouse gas emissions. That will cost money, which will increase the cost of electricity. Then there's consequences to that increased cost of electricity. So those two are tied together. Is it reliable and clean? So we talked about before solar power. It might be clean, and we're going to debate that. But just because it's clean, sometimes the sun isn't shining. So now, is it reliable? It's also, because solar power is clean, it is not as cheap as this other one. So all these three things have to be balanced together. And so that's kind of the focus of this lesson, is thinking about that as it relates to our different energy sources. So fossil fuels, as I said, they are cheap. They are the cheapest energy in most parts of the world. In the US, we have done some regulations and some subsidies that have helped wind and solar energy get cheaper. We're going to talk about that next lesson, the economics and the impacts. But fossil fuels are everywhere. They're abundant. We have them almost in every country. They're easy. They're just sitting in the ground waiting for us to pump it out or dig it out. So it's easy to access. We have an infrastructure that is built to move oil around the country. We have infrastructure that has these gas stations everywhere that we can use this energy. Electric power plants and the transmission lines that go with that. We have an existing infrastructure that's made for fossil fuels that's super efficient. So that's what makes it so cheap. But once again, what are we sacrificing for cheap? And I think when we talk about cheap, it's right now, what do I pay for electricity? What do I pay for the cost of my gas to fuel my car? We don't think about the long-term impacts of cheap, the impacts on human health or the environment. So cheap fossil fuels have it. Reliable, I would argue that fossil fuels are also very reliable. We have a large supply of fossil fuels, 50 to 200 years, probably more coal than we maybe have of petroleum, but we keep finding more sources of petroleum, more sources of natural gas. So we have a large supply of fossil fuels. Found almost everywhere. It's easily stored and transported because of its high energy density. So high energy density is megajoules per kilogram. Fossil fuels have it. No other fuel has that high of energy density. Once again, that existing infrastructure allows it to be like when I turn on my light switch, it's available to me. So that's reliable. In my mind, that's reliable. And we have global markets set up. So if there is a problem in one country with production, we can balance that production. It might increase the cost of that energy if some supplier drops out, but it is the fact that we will still have it. We still have gasoline. Even now, if Russia is dropping out, no one's buying Russian oil. We still have oil globally, even though they were exporting it. We are figuring out a way. It's going to cost some money. It's going to be a hardship, but in general, it's reliable. Which kind of gets us to is energy security and energy independence, does that make for reliable fuel? Because let's just, let's see, I want to go to this one. United States is energy independent. We have plenty of natural gas. We're exporters. We are about even with imports and exports of petroleum. So we export some petroleum, we buy some petroleum products back. So in general, we are energy independent with petroleum. We produce a lot. We're number one producer of oil in the world. We have tons of coal. We have lots of coal. Yet, if we look at this oil thing and what happened in Russia, we were going along here. This is 2018, 2020, 2022. This dip in the price of gasoline. So now we're talking about price of gasoline. This price of gasoline dropped because of the pandemic, supply and demand. There was too much supply, global supply, and didn't matter that the US was producing or not. It was a global supply and demand shift. And then over time, the prices increased because of supply and demand. And recently, with the incident in Russia and Ukraine, we saw a huge gasoline spike, despite the fact that we hardly have any of our oil coming from Russia. We are a net exporter of oil. So just because we produce our own oil doesn't mean that we are not at risk of some global events. We are in better shape, though, than the people in Europe right now. Obviously, the people in Ukraine are having issues with the war. It's a horrible event going on. But the challenge was with Russia, the power they had over everyone was because some of these countries, 100% of their natural gas came from Russia. So they were super vulnerable are super vulnerable because they don't produce their own. Europe in general is about 40% reliant for natural gas on Russia. So this creates a big problem when we think about the reliability of our energy supply. One, we have to produce our own like we do in the United States. We're still vulnerable, but even on top of that, if we're not producing our own, we are subject to other people's supply and demand challenges. So Russia's supplying 10% of the global production of oil. There's lots of production that could ramp up over the next 6 months. We will fill in that gap from other countries, but for right now, we are very vulnerable. Our supply of energy is not very reliable, or it's reliable, but just really expensive. Actually, I think in these countries, it's not reliable at all because they are so dependent. So I will pose the question, you can think about it, and then I have some answers. Is Colombia's energy system reliable? Are you energy independent? Are you energy secure? I don't know if I have the answer to that. I think that you guys should understand where you're at in the supply and demand of fuel. Did your energy prices go up with issues related to the pandemic, global event? Did your energy prices go up with what's happening in Russia right now in Ukraine? So you are actually in Colombia, you are an exporter of energy. About even with natural gas, you're using some, you're exporting a little, kind of almost even with natural gas. This is natural gas. This goes back to 2017. I couldn't find later data, but you're pretty close on the natural gas. You are a net exporter of petroleum products, and you have plenty of coal. So you are energy independent, if independence means we produce our own. But there are also issues with global supplies and other events that are beyond the control of the country. Also, I think about it as the oil and gas companies, unless they are owned by the state, they have the power to buy and sell gasoline and oil anywhere. So they are always on a global market. So they are selling to the highest bidder their petroleum or their gasoline. So that's how it works. And we as consumers are at the mercy of the oil companies. So summary, reliable energy is complicated. It's not as simple as we make our own energy, or that when I turn my lights on, it's most of the time the electricity is there ready to turn my lights on. We need a good infrastructure. We need adequate supply, but we also have problems with technology issues. Technology fails, refineries go down. We have natural disasters, hurricanes that take out a refinery. We have terrorism attacks on pipelines, on energy infrastructure, and I think that's going to be more common in the future. And then we have the global markets that we are not in control. No country is in complete control of their energy. Any questions on reliability? The concept of reliability, I think, is important, and I think we undervalue how good life is because we have adequate energy supplies. Talked about this, are fossil fuels clean? That was the biggest thing that you guys mentioned in the beginning. Human health, emissions when we combust fossil fuels, there's some gases produced, some particulates produced. It's really clear, all the science has shown that burning of fossil fuels, which is what we do, we burn fossil fuels, and that combustion is bad for human health. We also know that the mining, the drilling, the extraction of fossil fuels is bad for the environment, as well as the discussion about when we burn fossil fuels, we release XYZ gases that are bad for the environment. It's changing. Maybe it's acid rain, maybe it's some other sort of environmental hazard. related to fossil fuel production and use. And then finally, and what will be our focus, is this climate change issue. 73% of greenhouse gases produced by humans impacting the environment, or impacting the planet, the climate change issue, is from fossil fuels. So to look at this a little bit more in detail, and then we're going to break it up a little bit. So if we look at global greenhouse gas emissions by sector, because talking about greenhouse gases in general, like our energy system bad, greenhouse gases bad, doesn't help us. We have to figure out what are the solutions, and those solutions come in looking at where those emissions are specifically from and finding options for us. So we're not going to look at this. Agriculture and forestry land use changes, we are doing that. We have about a 20% in that agricultural land use changes. So if we change from a forest or a jungle or a grassland into something else, we are releasing emissions. And that release of emissions contributes to this total pie. When we are taking stuff and we're farming it, that is taking natural soils and moving them to farming, we are releasing emissions. We need those soils to grow food for the planet. So we're stuck with some of it, but can we do better? We're not going to talk about that today, but that is a big chunk of the pie. We have waste, landfills, our wastewater treatment plants for human waste, those emit. We have cement production, and other chemicals from industry that are emitting, not necessarily fossil fuel related. I want to talk about this one. This is energy use in industry. Energy use in industry is things like heat to produce products, or like we said, petroleum. 23% of the energy of petroleum goes to producing to produce products in industry. Plastic. So in this process, we're emitting greenhouse gas emissions. The two that I'm going to focus on here for the rest of the morning, and maybe only one of them, we're going to start with transportation. Transportation represents 16% of all greenhouse gas emissions from humans. 16%. So we need to look at that as a bucket. Say, what can we do with our transportation fuels? Then we're going to spend some time with energy use in buildings. So that's heating of buildings and the electricity that supplies these buildings and our energy use, whether it be commercial, industrial, or residential buildings. This one here, this pie here, is emissions that are related to conversion of energy from one form to another. Let's start with this transportation. 16% is in transportation. If we go back to this graph that I showed in the beginning, our petroleum is going 68 for transportation, and our 68% of petroleum goes to our transportation system. Our transportation system, 90% of all of our vehicle travel, plane travel, boat travel is done using petroleum. So what are the options then if we want to have cleaner transportation? This is a challenge that the planet is facing right now. We are so reliant on petroleum, but what options do we have? And I have come up with 3, and you can maybe shout out if there's more than 3 that I can think of. Actually, sort of 3. One is biofuels. It's sort of 2, biofuels and electric. So biofuels is ethanol, and biodiesel. Have you heard of these? So we're going to talk first about ethanol. Ethanol is a liquid fuel. It's an alcohol that burns clean, doesn't give off the gases and some of the particulates that gasoline has. It is produced locally. In Colombia, you produce it from sugarcane. In the US, we produce it from corn. So it's basically sugar being fermented and producing alcohol, same as the alcohol that you drink, same kind of process. it results in a 20% reduction in greenhouse gas emissions. So one of our options is to use that liquid fuel, ethanol, to replace gasoline. It's got a lower energy content, which is a problem, about 33% lower than gasoline. Good news is that it is a little bit energy secure because we are producing it at home. Anything that we grow at home and produce fuel out of, that's something that we don't buy from somewhere else. Negatives are, it is still costly. There are land use changes because we're growing a crop. Sometimes we're taking that cropland out of forest land or jungle. And so there's some issues with that. And then there's some impacts in general growing crops. Our fertilizer, our land use, all the things that go into growing a crop. Biodiesel is another liquid fuel that replaces diesel in our vehicles. So I want to just talk about this. In the US and in Colombia, there are mandates for ethanol. It's an E10, meaning 10% of the gasoline that you put into your, or the fuel that you put into your car when you're filling it, if you have a gasoline powered car, is ethanol. And your ethanol is grown completely at home, so that reduces the reliance on petroleum in general, and maybe the reliance on other countries for petroleum. That's important because of the cost issue here. So if we were going with the cheapest fuel, we would not be using ethanol. But because it's mandated, we're having to use ethanol. Same with biodiesel. Biodiesel, it's about, they call it B2 to B15. So up to 15% biodiesel in fuels, both in Colombia and in the US, depending on where you're at in the region and what's the availability of that biodiesel. So they're working hard to produce more biodiesel. It's a great substitute for diesel vehicles that add on. Once again, it's a crop. It's soybean oil, palm oil, any oil, vegetable oil, or fats, wasted fats, oils, and grease from cooking can all be converted quite easily to biodiesel. 50% reduction in greenhouse gas emissions, 10% lower energy density than diesel. Energy security, it's produced locally. The third option for transportation fuel, and we have to take some time on this one, is electricity. And so electricity could fuel our vehicles. Right now, those electric vehicles are expensive. And we also have to store that electricity. The electricity does not store as well in batteries as it does in gasoline. So that's one of the issues. Oops. So to talk about electricity and our electricity supply, and I'm going to run out of time, so I'm going to see what I can do here, and I might just end and then have some questions here partway through. So if it's an abrupt ending, that's what happened. When we convert one energy form to another, there is a loss of energy. It's not that energy is lost and we don't know where it went. The first law of thermodynamics says energy is conserved. We know that the energy went somewhere. We just don't have the ability to capture it. So when we take gasoline to power our vehicle, so chemical energy to mechanical energy, we are about 60% or more, 60 to 70% of that energy is lost as heat. Your engine gets hot and that energy is lost. So we do a horrible job transferring chemical energy into mechanical energy because of all those losses. Same thing happens with electricity. Our chemical energy, our coal, our natural gas, is converted to electricity, and we are losing lots of energy as heat. So we're losing about 65% of the energy as heat, and only about 35% goes to electricity to power our light bulb. And now our light bulbs also get hot, so they are about 90% thermal and about 10% is light. So we have horrible losses anytime we convert energy. And so when we talk about converting fossil fuel, that's a fairly good energy source, to something else like electricity, we have to know that we're losing a lot of energy in the process. 65%. So this is that chart looking at what fuels go into our electricity down here, and where it goes. Our electricity generated is done primarily through this rotation of a coil, a wire coil, in between two magnets, and when the coil spins, we're generating electricity. You've probably done experiments with this. So we drive this coil, the rotation of this coil, with the rotation of a shaft that is connected to something that's powering this, a mechanical system that's powering it. For most cases, it's steam. Steam turns the turbine. The turbine then rotates this coil inside magnets, which generates electricity. It's a simple concept, easily repeated, easily done. We have a lot. If you look at this, there's a lot of exhaust steam that's wasted, heat that's wasted. That's our 60% wasted energy from these thermal systems. Hydropower, it's much more efficient. It's about 90% efficient. The same thing, we are taking water to turn a turbine. The water is at a higher elevation, turns a turbine that then generates electricity. So water is our energy source. Is it reliable? And I would say it's reliable in that we have a pretty constant supply of water. Climate change is changing that. Maybe our rainfall doesn't come when we need it, so these reservoirs of water are not being filled up. So question mark on reliability. General, it's pretty good with reliability. So energy source of water, about 16% of the global electric source comes from hydropower. Once again, the thermal electric, that's that steam driving a turbine. That's about 73% of our electricity is done using this method. Energy sources are any fossil fuels, wood, or nuclear energy. Nuclear energy is just basically a way to generate heat to turn a turbine. Efficiency of these is really poor. It's about 40% efficient on most of these systems. Is it reliable? Yes, I would say that it's reliable because we can have a stockpile of fossil fuels there, and it's easy to just keep feeding that generator and producing electricity. Wind, it's the same principle that this now is the wind is the source of energy, and it pushes turbine blades just like a fan, blows your little fan to cool you off, blows air out. This is taking the wind coming in and turning the fan backwards basically to generate electricity. That's once again a coil turning inside magnets that then produces electricity that goes out here. Efficiency is about 20 to 40% efficient. Some of that comes with the wind is not blowing all the time. So there's lots of times when there isn't enough wind to make the turbines turn. Also, even if the wind energy, the actual energy in the wind itself, if you calculate that, it doesn't all end up as electricity. There's losses in the system. We can't turn the turbine just because of all this energy in the wind. Is it reliable? I would say that it's not super reliable because it depends on when the wind is blowing. Solar energy is the only energy source we have right now that is not part of that coil turning in an electric field, or coil turning in a magnetic field. It is direct conversion of photons of energy from the sun into electricity. Is it efficient? It's only about 20% efficient. The energy source is the sun, which is super reliable. The sun is super reliable, but it's a little bit like it's a cloudy day today. It's nighttime. So I would say in general, our solar energy is not that great with our reliability. A fuel cell, I just put this in here because this is, people talk about hydrogen, the hydrogen economy, and that is a function of producing electricity with a fuel, with hydrogen as a fuel. Efficiency is negative right now because of the energy required to make the hydrogen. And is it reliable? It would be reliable if we had a reliable source of hydrogen. So it's a question mark there. Right now, it's too expensive in most cases to do this fuel cell for electricity.